So we have the class system here. So now the class system would be like 1, 2, 3, and then we have from, let's suppose, 4 to 6, and then from 7 to 9. So now if you take the average, that would actually find out the x value, which would be actually 3 plus 1 over 2, which is equal to 4 by 2. So x, in other words, would be 2. Now next would be 10 by 2 would be 5, and that would be 9 and 16. So 16 by 2, which would be 8, right? So then you need to find out what is the x bar in this case, because we're assuming that it is some sort of a sample. And I told you there's going to be summation fx over summation f for sample or mu. If it is population, you take mu, right? So now this summation fx over, this is going to be summation fx over summation f. So now what is the frequency? Let's suppose the frequency is in the class system is the number of people that are in favor of some camcorder or handycam, where they're giving pointers to the companies which are making them. So now in this case, for instance, if they're rated as 1 to 3, the other is rating as 4 to 6, and the one that are rating them out from 7 to 9 out of 10. So there could be a number of people which are involved with this. Let's suppose from 1 to 3 is just 1, and then from like 4 to 6 it's just maybe just 2 people, and then this is just respectively, again 3 people, let's say. So now when you multiply fx, so okay, now class, just multiply with each other. So it's going to be 2, and then, sorry, the mark is drying out and I don't have sufficient material to write on the board. So I'll be switching on the book to explain the relative concepts to you, and this is going to be giving you 24. So when you add that 34, 36 is the summation fx, right? So when you divide it by summation f in this case, which is 3, 4, 5, 6, right? So that is going to be 6. So in this case, the x bar or mu for population would be 6. So now I'm going to be taking x minus x bar in case you want to find out the standard deviation, and then we'll be squaring them, right? We're going to be squaring them. So x minus x bar, whatever it is, it doesn't matter to us. We just want the values. So we have 2 minus 6 is minus 4, 5 minus 6 as minus 1, and then we have x is 8 minus 6 is minus it's 2, right? So this is going to be 2, and then we are subtracting from x because we want to find out the values in the order of the frequency with which they occur. Okay, class, so whatever the values that we have gotten, we're going to be squaring those values. Let me just repeat, this is the average we got. We are going to be, subtracting from the mean. This is the, whatever x bar that we had. So it's going to be 2 minus 6 minus 4, then 5 minus 6 minus 1, and then we have 8 minus 6 as 2. Usually you'll find such data which is going to be ending up in x minus x bar equal to 0, but let's just, for assumption's sake, since we have very few values, so squaring this 16 is going to be 1, and this is going to be 4, 21 we have, and divide. So this is again just summation x minus x bar, but we will be multiplying it with some value which has f with it. So for instance, if I have f with it, so with f it would be f into x minus x bar square. That would be 16, and that would be so again this is x minus x bar square. So again with the f, which is 2, so it's going to be giving you 2, and with f again this is going to be giving you 12, right? So again, let me just reiterate that you had x minus x bar, squared it, and then you multiplied it with the frequency. Okay, so you have the frequency as 1 into 16 as 16, 2 into 1 as 2, and 3 into 4 as 12. So now you just add them up again. So now you have 14 and 24. So this is again, you have 30. Again 30 you divide by summation. Now this is basically the concept of x bar. So it's going to be summation f minus 1. Had it been mu, we would be having as summation f. So how many values? So this is like 6, 3, 4, 5, 6. So now we are going to be having 5. So 30 by 5, right? So it's going to be 6 again. So this is going to be our variance. Again, let me just write this formula for you. Variance would be f into summation f, or it's just into x minus x bar square over summation f minus 1 for variance where there is sample, and where there is population we'll have summation f. And then we're going to be taking the under root of that. So since we had 6 here, so we'll take the under root to get standard deviation, and that is all about the group data. Okay class, next we are going to be considering the geometric mean. Okay, and then we're going to be reverting to the book for further clarification, where I can guide you how to solve the questions. So geometric mean is basically just RG. This is now the constant return. Okay, and this is the growth factor also. So initial investment could be like maybe $12,000 into some initial value R, which is actually the formula for compound interest for number of periods, right? So now this could be the geometric return for the reason that we want to find out that the return for successive years that the investment is going to give us. But sometimes when we take the mean, it does not give us the true value, right? How we don't get the true values, because sometimes it could just nullify and not give us the accurate return for the next year that is involved. So then we take basically the initial investment, and then we can just simply first of all we find out what is the value of this function. So what is the formula and what is the logic behind it? I'll just explain to you that since we have RG, so we're just going to be removing the square, and we know that basically 1 plus RG is actually 1 plus R1 into 1 plus R2. Okay, so that is because of the respective periods that are involved in this, right? And then since this is squared and we want to remove the square, so that means we have to multiply this equation with half and this whole with half. And we know that this half is actually the the under root, so we're going to be keeping it as 1 plus R1 into 1 plus R2. And then since this is cancelled out, so it's going to be RG is equal to, and then minus 1, because we'll be displacing, putting it on the other side, the right hand side. So that is the logic behind this. So once you have the value of RG, which could be 7% or 8%, and then you can just simply multiply it with this value. So for it is like, if for ease sake you say that if it was 2%, so it could be 2, you have, so it's going to be like $240 of return for the initial investment at 2%. This is how you find out the geometric mean of the investment in the second year, because you see what is the growth in if you were doing the mean basically. So we would be having in the first year the investment would be, let's suppose again we take the initial example of 400. Second year it was 500. So that would be 500 minus 400 over 400, right? So it could be, like maybe 100 by 400. See? So that means that we have equal to 1 by 4, which is actually, again, so we can just have, as, okay, so now you can assess what is the value of the return that we have. So it's, so, you have, you just simply have, so it's again 5s are 20, so you can just have 0.25 as the returns is 25%. But then if, for instance, in the second then third year you again reduce from 500 to, let's suppose, 400, so that means it's going to be 400 minus 500 over, again, now since this was from 500 to 400, then it's going to be divided by reducing second to original and then original. So it's going to be giving you again a minus of 25%. So that means your next, the net would be 0, right? 25%. So that means this mean system is not successful in this. So for first, second, and third successive years, this is not going to be giving us a true picture. So for having the true picture, we just simply multiply with the returns that are with us. So for instance, if this was the third year, again, we would be having some kind of return, which will be, as per calculation, 25% or minus 25%. So we can just have 1 plus, then you have again, let's suppose was 0.02, and then 1 plus 0.25, and then 1 plus minus 0.25. So that means that, this value would not nullify this entire, thing. So it's just going to remain perhaps the same, but it won't, anything multiplied here, or having the sum as cancellation effect would mean that our initial investment was just, it never existed, because the first would give you the initial outlay, and then the second year you have invested, but in the third year that was divested somewhat. It had a negative effect, so this just gives you a 0 instead of giving you some value here, but this is not going to be giving you a 0. So they just multiply and then just give you a sum. Then you can just simply add it up and look at this. Alright class, let me just look at the questions. Now in 3.40 is basically about this entire process that I've already gone before. You can just simply log in and see the procedure in this example. They have just repeated all the steps here with the frequency, with FM, and then finding out sample variance in another example. So you'll have another whole situation in front of you. Then you can have, this question now. It says that consider calculating a student's grade point average using a scale where 4 presents an A and 0.0 presents an F. Explain why the grade point average is a weighted mean. Now the reason for it is that because we are using the credit hour system. So for credit hours, the weighted mean has to be the the hours that are with respect to respective scales. So grade point average with the hours and the grade point would mean that the full hours in the first place have to be taken for the student to be graded in the first place. And in the second step, we know that if he is getting a 4 with respect to the grades, then those grades would be considered as the weights for that particular student. So that is the way we take the weighted mean. It depends upon what weight would give you this output. So in other words, we have the input and then we have the output, or what amount of examination level would give you this output. Then we have another question. Let me just focus on the, okay, probably won't be able to see it from here. Now these are the number of radios sold, okay? Now how are you supposed to do this? Consider this Sound City sells the top of the line satellite car radio over the last 100 weeks. So how do you find out the 100 weeks? So they have already given you that this is a sum. So this would be like summation of, W or something, maybe. What have they asked us to do? Weighted mean. So this is basically the weights we have, and then we can just multiply it with this. So we can have W and X as such. So you have to look at the data to find out what is weight and what is X. So just 3 into 0 and 20 into 1 and 50 into, so it's going to be something like, you know, to the point of 3 into 0 and 20 into 1, where this would be as you know, X, and it's going to be treated as W. So you can just simply solve it and divide it by summation W. In this case is 20 plus 3 plus 20, and then 50, 60, 70, 80, 90, and this 5, 6, 7, and 8, 9, 10. Right, so it's going to be 100 divided by 100. Summation Wx divided by 100. So again, now this is a class. Okay, now this is also weighted average system. Over here you're going to be taking as weights these values, and this is going to be the grade points converted from A to 4 and then from B to 3. This is the GPA system. A similar technique is involved in this, and then there is another question here. We have the weights and the frequency, and now like I told you, the class system where we have the weights, so it's just going to be, you know, adding them together. So it's going to be something like, my marker is not working, I'm really sorry for this, but 1 plus 3 divided by 2, 4 plus 6 divided by 2, 7 plus 9 divided by 2, and 10 plus 12 divided by 2, right? So this would give you 11. This would be giving you, you know, 16, and this would be giving you 16 by 2. This is going to be 22. This is 11, so it's going to be 8. Sorry, just let me write the whole thing as 8. This is 10, so this is going to be giving you 5, and this is going to be giving you 2. So you add them together, 18, 19, 25. And there are 4 values approx. So you can just simply find out the frequency. In this case, you can't just simply divide it by n. Over here, you can just simply add the frequencies together, and there will be summation f, and you divide it by summation f in this case, because since we are doing the frequency, so we also have to you know, summation f into x. Okay, so we also have to multiply this with, you know, f, so that we can have the summation fx here. So again, now this was, let's suppose, x. So now summation for fx, we have again 53 into 2, then 118 into 5, and we have 21 into 8, and 3 into 11. Okay guys, so you just, this is summation fx, and then you can just simply multiply it with frequency. So you can have a value which will be divided by, again, the total, this value, the sum of this value. Okay, so you can just do the question, and sample variance would be just as per the formula. Then this is x, and then you can have x bar. What was the x bar in this case? So this is summation fx. Let's just calculate the summation fx. Okay, for starters, let's just 53 into 2. I hope you can see this. Into, let me just focus on this. 53 into 2, we have 106. And then we have 118 into 5. We have 590. So this is 106, we have 590, and then 21 into 8. So we have 21 into 8, and that approximately gives us 168. And this is again 33, just convenient. So just add these values up now. So it's 168 plus 33 plus 590 plus 106, and you have 897, right? So this 897 is like your summation fx. So I'm going to be writing 8 summation fx over summation f, which is actually x bar, is equal to or the mu, whichever the they refer to the data as, whether from population or sample. So it's going to be 897 by the how much is the frequency. Now you can just sum this up as you can see, this is 53 plus 118 plus 21 plus 3. So it gives you about 195. So you just divide it by 195, and then you can have 897 by 195. I hope I'm not making any mistake, and this 4.6 is the mean average. Then you have already the x, which is the the average of this, which was 3 plus 1. This is 4 by 2, then this was 10 by 2, then it was again 16 by 2, and then we had 12 and plus 10 by 2, so this was 22 by 2 is 11, and then you multiplied this with the frequency. The frequency values were given to you, and then you added them up and divided by summation f. But remember that for variance you'll be having, if it's sample, like I said that it is sample, so you're going to be dividing by summation f minus 1 instead of summation f. But for mean you don't divide it by summation f minus 1. And now similarly is the other, I think, probability distributions. You can do those. Let me just go back to section for geometric mean. It's very simple. Let's just see if I can go to the section where, okay, so this is section 3.5. Let's just go to the geometric mean, which is section 3.6. Oh, it's not giving us at this. Oh, just wait. Okay, class, now you have the value. Suppose that initial investment of 10,000 increases in value to 20,000 at the end of 1 year, and then decreases in value to, like I explained to you about the geometric mean. That means that for year 1 you have the second value minus 1 over minus the original over original, and then in the second year you have the primary value again being returned in a negative fashion from 20,000 and decreases to 10,000. So that is the second value minus the original, now which is 20,000 in this case. You have minus 50%, right? So you're going to be dividing it by 100 to just get 1, and minus 50% over 100 is going to be just again you'll be removing this point minus 0.5. However, this is a wrong way to do it, because if you can just simply see that the average that they're talking about here, if I'm just going to be highlighting this portion, it's just 25% return. So this arithmetic mean is not the true picture. It doesn't change at the end of the 2 years, whereas you know that they have really suffered loss in the second year. So it does not give us a true picture. What we really want is, like I told you, that we have the initial investment as per this. We have our G. You can just simply get this equation. You have 0. That means that now you can't really in this fashion cancel out and then average it out. So but in fact now this is the value in which you can just have the true effect that you're not getting any benefit out of it, right? So this is what you get in the end, RG, but then you multiply it with the initial investment after you have added it with 1. That means that the initial investment would return in itself. You're not going to be overall having the 0, but you're just having the same investment. It means that the value remains unchanged. So if in the third year, let's suppose if it was rising to 25,000 and minus again, then from 10,000, since it was in the second year 10,000 reduced from 20,000, so it was again the third year 150%. So now you're just going to be adding the third part, and you can just simply as a compound interest formula, you can just simply adjust the value and you can have the return. Now this is the question again, 3.50. So you can see that the company's sales, okay, let me just bring it closer to you so you can see. company's sales were 5 million years ago. Since that time, sales have grown at 10%. This is very simple for you. They've just simply given you the rates. So it's so in this case, RG would be 1 plus 0.1. So 1 plus 0.1, and then again to 1 plus, what is the second rate given to us? Minus 10, so it's going to 1 minus 0.1. And in the third year we have 25%, is going to be 1 plus 0.25. So you just simply see this is 1.1 into 1. Let me just calculate for people who don't know. 1 plus, actually this is 10%, right? So we have 0.1. So this is 1 plus 0.1 into 1 minus 0.1. So it's just going to be 0.9. 1 minus, let me just 1 minus 0.1, and you get about 0.9, and then you have 1 plus 0.25, and you have 1.25. This is 1 plus 0.25, you get 1.25, 0.9, and then 1.25, and then you can just simply have the under root of this and minus 1. So you get RG for the third year. This is actually the cube root now, because you had this as 1 by 3, right? So this is going to be the cube root of this. So for nth year, you'll have n value of this, right? So you can just multiply it with the initial investment to find out what was the value of the initial investment. Was 5 million. Growth rate over 3-year period, and find the ending value of sales after this 3-year period. The ending value would be just simply multiplying it with the third year process, and then over 3 years, what is the G? So in the first part, you're going to be finding the G and then multiplying it with the initial investment, which is going to be any value that you have. So it's I don't know if I have the functions. Let me see if I have this. Okay, we have the under root here. So we can have 1.1 into 1.9 into 1.25. So you have 2.6125. Okay, so this is 2.6125, and then you have to take the under root of that by cube actually. So this is the cube root. So I think it is going to be 2.6125 of cube. So kind of this gives you 1.3772. So 1.3772 minus 1 would be like 37%, sort of. Minus 1, again we do minus 1, and you have 0.377. Then this is RG, right? So then we have the 1 plus 0.37, okay, into cube, and then this would be into the initial investment, which is 5 million in this case. So then you'll have then sales growth and how much sales grows by the years, because they have been declining at annual rates, and the formula is very simple. You're just going to be having 1 plus R1, R2, and then R3 as 1.5, and then minus 1. So this is 0.35 in this case. Again, that in our case was 0.37, simply multiplied with the initial investment. I think this is, again, for this question, you're just going to be individually calculating. For 2008 year, you have these values. For 2009, just calculate them horizontally if you can for various values, or you can just even calculate for vertically for one company, and then second company, and the third company. And that's the cross section would basically tell you about the performance of all the companies for 2008. But if you want to do it vertically, then this would give you the performance of DJI, and this was NASDAQ and S&P. I hope that you have understood this. Next would be, we'll be talking about the probability. So just see you, and just try to, practice these so that we can just gain further for as a foundational, learning basis for the next class. And see you then. Thank you so much.